Welcome to my YouTube channel. My name is Dr. Emmanuel Nwese, lecturer at Alex Ekweme Federal University, Nufali, Nigeria. The topic for discussion today is Lagrange interpolation. Course title is Introduction to Numerical Analysis. We intend to implement Lagrange interpolation using Jupyter Notebook. The method that underlies this Lagrange interpolation is presented as follows. Usually, we are given n+1 tabular data as shown on the screen, where x0, 1, and xn with the corresponding y0, y1 up to yn are numbers. We are expected to find an interpolated function, usually n-degree polynomial, which is given in this form, Pn of x, which is the summation from I equal to 0 to n of a function Li of x and yi. This summation, we define Li of x as the product from j equal to 0 to n of x minus xj over xi minus xj, where j is not equal to I. Usually, pi is a product notation. So when we say I from 0 to n, x minus xi, what we actually mean is taking the product from I equal to 0 to n, as we can see in the right hand side here, x minus x0 into x minus x1 up to x minus xn. Now, let us see a simple example here. Now, we have a data, 4-point data. The x0 is 0, x1 is 1, x2 is 2, x3 is 3. So n equal to 3 in this case. So we're looking for a polynomial of degree 3. In this form, we'll take L0 x multiplied by y0. Then we'll add it to L1 of x multiplied by y1 up to L3 of x multiplied by y3. Then, how do we compute the L0 of x? Here, we look at the numerator very well. You find out that x0 is not used at the numerator. Instead, we subtracted x1, x2, and x3 from x in each bracket. At the numerator, x0 is the first term, usually in each bracket. So we have x0 minus x1, x0 minus x2, x0 minus x3. Now, the same procedure is used in L1 of x, as you can see here. We continue in this way up to L3 of x. That is the basic definition of that function P3 of x, as shown above. Now, how is it implemented in Jupyter Notebook? First, we import numpy as np, which is the model we use for calculation. And then we need to also import the symbol from SymPy so that it can hold our x value, which we look at as a symbol, as defined in this line here. Then the values of x and y in that table will be stored in xd, yd as numpy arrays, as shown here. Just after that, we define the exact function that gave us those values. We just added that so that we'll be able to find out how close our solution is. The exact function is defined by 1 plus 5x minus 3x squared plus 2x cubed. Now, we need to lay out the numerator and the denominator of that product. Here, we use L for the lower uh, lower number at the denominator, and U at the upper number at the numerator. Now, if J is not equal to K, as shown here, then we can take the product of X minus SD of J from J equal to 0 to N. Actually, from 0 to N minus 1 because of the function called range here. Now, this function Lk will return the fraction U over Lk. Now, we'll look at the Lagrange itself. Using that Lk, we'll now multiply by Yd of K as demanded from the formula. Then Ff of X will just get us the Lagrange at X using 4 points. Now, if you run your program, then you will now get what we have here. This is our solution. Now, we want to plot that to see how it will look like. Import all the necessary modules for putting your graph in Jupyter Notebook, and then first of all, we show the point xd and yd, which is the data given, and then xd and y cap. Y cap is the polynomial which we got from that formula above. We now have the plot as shown below. You can see that we have first point, second point, third point, and the last point, which is the fourth point. And then the interpolating polynomial is equal to P3 of x, since we had n equal to 3. And at the given point, P of 3 is exactly at the same point. Okay, that's fine. Let's look at, well, supposing we extend the points from 0 to 50. How will this function behave? Well, let us take the exact function values at that point from 0 to 50. And then let us also take the value of the polynomial, which we obtained above, as PV. And then we plot all this again for us to see. Look at that. That's what we have. So we now have the data points are there. The f exact function is also there, which coincides with f50 of x at those points, at the point from 0 to 50. At the given point, you see the f exact and the polynomial of degree 50 at the same value. Beautiful. This is what we do when we're trying to implement Lagrange interpolation using Jupyter Notebook. I hope you enjoyed this. Thank you for watching. Bye.